Hey, what's up, class? We have lesson 717 today. We're going to skip 716. And it is going to deal with some shapes that are irregular. We did this when we worked on area. We had to like find missing lengths of sides and things like that from these weird looking shapes, whether we were designing pools or houses or things like that. That was a while ago. I hope you remember it. If you don't, I'm going to show you how to do it. And rather than find area this time, we're going to find perimeter. Let's take a look. Now, the first thing you're going to see today when you do your work is you're going to have to find things from like regular shapes. So you'll have a triangle, for example, and it might be labeled. So the idea here is that all the shapes, all the sides of this are the same. So if that's 4 centimeters, they might just give you that. You have to then figure out, well, that must be 4 centimeters, and this must be 4 centimeters. And if that's 4, 4, and 4, this is called an equilateral triangle, by the way. If anybody ever asks you in the future, Mr. Burnell taught you this time when you're in 3rd grade. Equilateral triangle means that that side, and that side are all equal. So 4, 4, and 4, 12 centimeters. So you'll see a couple problems like that first when you do your problem set today. And then we move on to a little bit more in-depth stuff, and you might see some shapes that look like, this was a bad idea to try to draw this by hand. We're just going to pretend that all these are perfectly straight. Actually, for Mr. Burnell, that's not too bad. And you might get all of the sides to start. So you might get like 8 feet, 4 feet. Let's make this 5 feet. This is 3 feet. We'll make that 4 feet. And then we'll make this 7 feet. Okay. And if you have that, if you have all that information, then this is no different than any other type of perimeter problem, in which case you just add them up. So you pick one spot and you add up around. So I'll do a different color here, but I might start down here on the bottom left-hand side of this, and I might go in this direction, and I might say 8 plus 4. So now I've done that one, I've done that one. I find it's helpful to like check them off as I go when I have more sides like this, because otherwise I forget a side. Plus 5, plus another 4. It's especially helpful when there's a bunch of measurements that are all similar. Plus 3, plus 7. Now I'm going to go through and add this up. So 8 plus 4 is 12, plus 5 more is 17, plus 4 more is 21, plus 3 more is 24, plus 7 more is 31 feet. So a couple of key things to review there. If you have all the side lengths given to you, it's as simple as picking a spot and going around the perimeter, the outside, and adding them up. And I find it helpful to check them off or slash them as you go through. That way you ensure that you get every single measurement. Those ones are relatively simple. The shapes are going to look odd to you in some cases, but the process is the same as if you were, going around a regular rectangle, right? You pick a side and you go in that direction, that direction, that direction, and back to the start. So same process, just different type of shape. But you will be asked to find the perimeter of shapes that are irregular and you're not given all sides. You have to figure some out. So for example, wow, that was bad. I might have something like this. All right. Again, pretend these sides are straight and pretend that that is connected there. There we go. And so I might be figuring out that this is 10 centimeters. I might know that this is also 10 centimeters. We'll make that 8 centimeters. I might know that this is 2 centimeters. Okay. And that might be all that you're given. And then you have to look at this for a minute and say, okay, what do I know and what do I need to figure out? Well, what I know is this is basically a rectangle, right? If I brought this section up, that would complete a full rectangle. Okay. So if this side is 10, then the opposite side is 10. So I can label that in. Actually, you know what? I'm going to do that in a different color. The ones that I didn't know at the start, I'm going to put it in a different color. So I'll make that also 10 centimeters. This and this look the same to me, or about the same. So if this is 8, and we already know that 2 exists, then there's 6 centimeters remaining to go there and there. So I'll call that 3 centimeters and that 3 centimeters. And then I can get rid of my my 6 up there so I don't confuse myself. I was just putting that there to show you why I was labeling these 3 and 3. And now I have everything labeled. So now I can pick a spot and I can go in that direction. Go 3 plus 2. Actually, you know what? This is even easier. 3 plus 3 plus 2 is 8. So that's 8 centimeters. That's 10 centimeters. That's 8 centimeters. That's 10 centimeters. So 10 plus 10 equals 20. 8 plus 8 equals 16. 20 plus 16 is 36 centimeters. So that's one type of problem that you might get where you have some missing sides, and then you might get ones that are slightly more complicated than that as well. That one was relatively straightforward because it essentially was a rectangle. You might have something in this sort of shape. Okay, and then when you have that, you might have some measurements given to you. I'll put those in black. And you might have this being 3 centimeters. You might have this one being this one. I'm going to draw this one on the inside. You might have this one being 5 centimeters. So that 5 goes from there to there. This 3 goes from here to here. Okay. And then you might be told that up top is 7 centimeters. And you might be told that this over here is 8 centimeters. And then you need to solve the rest. So where do I start? Well, I start with what I know, and then I figure out what I don't know. So by that, I mean, if I know that that's 7, and I don't know what this is, but I know that 5 is like I have to go from here across to here, like right, that's 7. Well, I already know that that's 5. Like up to that point is taken up by this 5. So 5 plus what equals 7? 5 plus 2 equals 7. So that must be 2. Do you see what I did there? So if this entire top length is 7, then the bottom length must be 7 as well. So like if I go from one side to the other completely, that's 7. And I already know that I have 5 up to this point. I just need to find the remaining side right there, length, which is 2 right there. Okay. I can do something similar on this side. I know that the entire length, I'll do it in another different color. This is gonna be a really colorful drawing this time. So I know from there to there is what I need to find, right? But I know that if I extended this all the way down, it would be 8. Like that entire length is 8 centimeters, right? Well, again, I found out already that 3 of that is already taken up by this 3 over here. Like that side right there is the same as this length right here. That length that I'm using to figure out what is up top here. So if I said 8 minus 3, I'd be able to figure out what's remaining here. And 8 minus 3, as we know, is 5 centimeters. So if I now I'm at the point where I can solve because I have all of my side lengths all set. I'm going to erase all the extra stuff in here so it doesn't confuse us. Whoops, that's not what I want to erase. And I'll do one more example for us after this because I think this one might have been a little bit confusing. But I'm basically going to pick a point again. And I'm going to go around, and I'm going to add 7. And then I'll go down this way, plus 5. Still going to check them off as I do them. And then I'm going to go in this way, check off 5, and go down this way and check off 3. I'm going to go this way, check off 2. Wow, that was a weird 2. That's better. And then finally, I'm going to go back up to my starting point, which is right here, and check off 8. So if I have 7 plus, well, 5 plus 5 is 10. So 10 plus 7 is 17, plus 3 is 20. I know 8 and 2 is 10, so I have 20 plus 10 equals 30 centimeters. Mr. Burnell didn't do a wonderful job explaining on this problem, so I'm going to do one more. I thought I sort of talked too much during that example. It's probably slightly confusing. So we'll give you one more try at this. Let's see if I can be a little bit better with my drawing here. You might have something that looks like this. It's like that. And let's label some sides. This entire length from here to here is going to be 14 feet. This side right here is going, this from like here to here is going to be 7 feet. This going down this way is going to be 4 feet. And that's all I'm going to give you. And then we're going to see if we can figure out all the rest, which we can. So we're going to, all right, there we go. We got a new color. So here, I'm going to go through and highlight what it is I need to figure out. I already know everything on this side, so I'm good on this side. I already know this top, I already know this bottom. So I need to know, or that side, not bottom. I need to know right here, which goes from, I'll label all these in different colors, from there to there. I need to know from here to here. And I need to go from here to here, this entire bottom length. All right. So how do I do that? Well, I'm going to start with this length over here, the orange. Start with the orange. Because if this entire length is 14 here, right? But it includes from there to there, which is 4, because that's a rectangle, like this little rectangle up top. This is 4 right here. So if I have 14 take away the 4, that would be 10. So which tells me that this part of the rectangle, the bigger part of the rectangle, is 10. So if this side's 10, the opposite side is also 10. That's just a property of a rectangle. So we have our orange one done already. Now, over here, I'm going to say that this is taking up half of the space up here. So if this is 7 from here to here, this is actually sort of an assumption is dangerous to make mathematically, and my high school math teachers would be telling me that this is incorrect, but we're going to go with it since we're at 3rd grade. This is halfway, right? So if that's 7, if the length from here to here is 7, then the length from here to here is also going to be 7. Okay? And if this is 7 and that's 7, if I have 7 here and 7 here, those added together is 14, and 14 is the length I need for down here. Now I can go around and I can start adding things up. Let's pick a new color for that. Let's start there and we'll go clockwise. So I'm going to go 7 plus 4. Sorry, it got a little loud as my neighbor drove by there. Plus 7. Now I'm going to come down this right side, plus 14. I'm going to go this way. plus 14. I'm gonna go back up. Whoops, I'm not checking things off. Plus 10. So I have 7 plus 7. I'm going to cross those out first. That's 14 plus 4 plus 14 plus 14 plus 10. Oh, look at that. I can combine that 4 and that 10 and make another 14. So I have 14 times 4, basically. 4 groups of 14. And we can figure out that that is basically the same as 14 times 2 times 2. Because I'm breaking that 4 into a 2 times 2. I'm going way back now to review, guys. We did this a long time ago. 14 times 2 is 28. 28 times 2 is 56 feet. That problem right there reviewed all kinds of previously learned stuff. I hope that that one made more sense. The hardest part of these for you is not going to be adding up the actual perimeter. It's going to be finding the missing pieces. And that was the case when we did this with area. So the good news is you've had experience with the most difficult part. The most difficult part by far for third graders is finding the missing portions of these shapes. Once you have figured those out, adding up the perimeter is going to be relatively straightforward for you as long as you're organized about your process. Give that a shot. Let me know if you have any trouble with it, and I'll be happy to review it with you again if you do.